Okay, so we're going to get into parabola equations, but before we do that, I'm just going to try to tell you a little bit about the picture. So the big thing about the picture is every parabola has a vertex, and you can find the vertex by looking at your h and your k value once you have the equation. Every parabola will have a focus point, and that focus point will always land in between the arms. Now, you'll see the distance from P is going to be the same distance down here, and this thing we call the directrix. And this directrix is just used to do the picture if we were actually doing a construction. And I'll show you something about that in a second. The distance all the way across is going to be your lattice rectum. The lattice rectum distance is 4 times P. And the interesting thing about it is the further away P is, the wider the arms get. So there's a direct correlation between how wide the arms are and the distance between the vertex and your distance between your arms. This is an example right here of what the focus and directrix is used for. If you pick a point specifically on the parabola, the distance from the parabola to the focus should be the same distance as the parabola to the directrix. So as you can see, that's just a thing that's used for the drawing. Okay, so your parabola can face one of 4 directions. What I like to do is I like to narrow it down to either up or down or left and right. And you can tell which one it is based on the letter that's on the right inside the parentheses that doesn't have the exponent. That's another thing that's unique about this equation. Every other problem we did had an exponent of 2 on both the x and the y. This is the only shape that only has 1 exponent. So I want to talk about the p-value. You'll notice the formula, it's got a 4p out in front. The sign of p is going to determine which side to move the focus point to. So if p is positive, that means if you have the vertex here, a positive p-value in front of this y means that you have to go up. If you have a vertex here and you have a negative p-value, your p-value here, because we're only allowed to go vertically, means that negative is down. If you do the same thing over here with the x, if your p is positive, if you look at your vertex, this is your vertex here, a positive p-value along the x-axis means to the right. And the same thing for this guy right here. If your p-value is negative, that means that you're going to have on the x-axis, if you go in the negative direction on the x-axis, you would go to the left. Now, if you guys pay attention to the order of the letters, you can find the vertex the way we've been finding it in every single example that we've ever done. It's going to be H and K. But just remember, you have to pay attention because the orders aren't always alphabetical. So here's what we're going to do. We're going to start off by finding the vertex. Okay? So the vertex here is going to be at 0, 0 because it doesn't have any parentheses. Then what we're going to do is we're going to take a look at the unsquared letter. The unsquared letter on the right is the letter Y. So immediately that narrows it down to 2 choices. You're either going to have a parabola that faces down or a parabola that faces up. To figure out which way specifically it goes, you're going to take the number from the front, this guy right here, and you're going to set it equal to 4p. Now what we're doing here is we're actually finding the distance between the vertex and the focus point. So if I just divide this by 4 and divide this by 4, that means p is equal to positive 1. So if I have a graph that's going down or up, because this is a positive, that means that it's got to go up. So that means that our focus point would go up 1, and we put the dot right there. So this is the shape. Now the reason why that's significant is that we can adjust some of the numbers based on the direction we have to move. So if I have to go up 1, I'm going to add 1 to the y value. So that's going to put us at 0, 1. Now because the focus point and your directrix are opposite of each other, that means that I could also go down 1 to get to the directrix. So to go down 1, I would just subtract 1 from the y value, putting us at negative 1. And because we're messing with the y value, that means that the equation is going to be y equals negative 1. So I'm going to show you that pattern again because we're just going to redo this pattern over and over and over. So the vertex is going to be at 0, 0, because this doesn't have any parentheses. We're going to look at the letter on the right because that's going to narrow it down. Because remember, we have 4 choices. It's either up and down or left and right. So we need to narrow it down to 2. So this graph, because the x is on the right, means that the parabola itself has to either go left or right. To figure out which direction we have to go, we're going to take the number from the front and set that equal to 4p. So if I divide by 4, I end up with p equals -2. So what that means for us is on the x-axis, because we're moving left or right, this right here means we have to move left. So that would be this graph right here. We go left 2 and we put a dot. So this guy right here, this is the shape. And the reason why that's important is because that tells us how to address the numbers. So because I'm moving left, I'm going to have to take, and I'm going to use red on this one, I'm going to have to go to the x value and subtract 2. So 0 take away 2 would be -2, 0. And then the directrix is always going to be in the opposite direction. So if I go in the opposite direction, that would be +2. So I put a +2 right here. I should have used probably a solidly. So let's go +2. So that's going to be a +2 for the x, and because it's x, it's going to be x equals 2. Okay, next, now it actually has parentheses, and pay attention to your vertex, because remember, there's 2 shapes now where the letters could be out of order. So this one, a lot of kids mess this one up because they'll put 2, -1, but it's supposed to be -1, 2. And then we're going to take a look at the letter on the right. The unsquared value is going to be x. So again, it means our graph has to go left or right. We're going to take 4p and set that equal to the number out in front. So set that equal to 8. So we divide by 4 and divide by 4. So p equals 2. And because it's a +2, if I have only 2 options, left or right, a +2 means right. So it would be this picture here. Go to the right. So if I'm going to the right, I'm going to have to go to my x value, and I'm going to have to +2. So this is going to be +1, 2. And then the directrix is always opposite. So if I went right 2, that means I have to go left 2 to get to my directrix. So left 2 would be subtract 2. So that's going to be -3. And because we're messing with the x equals -3 is the equation for the directrix. Okay, next, the vertex, there's nothing special about this one because this one is in order. So it's going to be a -3 and a +2. Now this one has a y on the right, so that means the graph has to either go up or down. So we're going to take the number from the front and set that equal to 4p. Divide by 2, or not divide by 2, divide by 4. Divide by 4, and p is equal to +2. So again, I only have 2 options. It's either up or down. Because it's positive, it's up. So that means that it has to be this graph. So the focus point would be inside the 2 arms. Because I'm going up, that means I have to play with the y values. So I'm going to have to add 2 to go up. So that's going to make this at 4 with an x value of -3. And then to go in the opposite direction, I would subtract 2. So I would put us at 0. And because we're messing with the y, it's going to be y equals 0. Okay, next. Now we have to find the stuff that doesn't have parentheses. So I'm just going to do this problem like we've done every other problem. I'm going to scoop this stuff way over here. And I'm not going to mess with it because it's kind of like on the side where the 0 usually is. So I'm just going to start off by completing the squares. So I'm going to put x plus 2 in the parentheses. Because remember, you always divide to go here and then square it to go back. And that's going to make a +4 that was not in the question. So to undo the +4, I'm going to put a -4 over here. So basically, if I rewrite the problem, it's going to have an extra -4 right here. And then we're going to have the equal sign. I'm going to bring it back to so that it's closed again. So it's going to say y -1. And I need only the parentheses on the left. So that -4 has got to go. So I'm going to take the -4 and I'm going to add it to the other side. So here's my final equation. It's going to be x plus 2 squared equals y, was that +3? Now, we're supposed to have two parentheses, and anytime you have a plus or a minus sign here, we can just put parentheses here because this technically has a 1 in the front, okay? So now we can find all of our stuff. Our vertex is going to be at -2, -3. And then we're going to look at the letter on the right. That letter on the right has a 1, or it has a y on it, so that means it's either up or down. We take the number from the front and set that equal to 4p. So I divide by 4, divide by 4, and guys, I don't even care that this is a 1/4 or 2, what is that, 0.25? Because I'm either going up or down, positive means up. So that means that this graph will be really close here. So it's got to be this guy right here. So if I'm going up, I need to add 0.25 to the y value. So that's going to make this, what's that going to make this? -2.75. And then I'll put -2 for the x value. And then I need to go down -0.25. So that's going to make this -3.25. And then, oh, I'm not doing a point for this one. Sorry, it's an equation. So 0.25. So this is -3.25. And because we're doing the y there, it's going to be y equals. I'll show you that process again. Now this one doesn't have all the stuff separate like the previous one. So in this guy right here, you've got to remember, I need those loners kind of pushed off to the side. So I'm going to take this -4x, this -3, and you can even throw in the equal 0. It doesn't really matter right now, but we're going to complete the square. So this guy right here, it can be y plus 1 squared, which is going to make a +1, which we're going to have to undo with a -1. And because these guys right here, let me show you what we have. All of these parentheses right here, I'll do it in yellow. All of this turned into the parentheses. So that means that we also have the -1, and we also have the -4x -3 equals 0. So all the stuff is together on one side. So what we could do is we can combine the -1 and the -3. So this is going to be -4x -4 equals 0 with a y plus 1 squared. And then we want the y plus 1 squared all by itself. So we're going to add 4x to the other side, and then we're going to add 4 to the other side. So all of this cancels, and now we're left with y plus 1 squared equals 4x plus 4. Now on the right side, we still want parentheses, but if you notice, they both have 4s. So what we could do there is we could divide out the 4 and put it as the GCF. So this is going to be x plus 1. And on the left side, we have y plus 1 squared. And now we can do all of our stuff. So the vertex, be careful with this one because the letters are backwards. Now, fortunately, it's got the same numbers in both spots. So it's not going to matter if you write it backwards because it's going to be -1, -1. The letter on the right is x, so that means the graph has to go either left or right. So we take 4p and set that equal to the front number, so 4. And then we just divide by 4. So p is equal to +1. If I'm going on the x-axis, left or right, a +1 would have to go to the right one. So that means that this graph would look like this. Right 1, and then there would be a dot right here. So that's the graph for it. And guys, the reason why I do the graph is so I can tell which number to mess with. If I'm going to the right, I have to mess with the x. So I need to go right 1. So right 1 would be +1. And so if I'm at -1 and I add 1, that's going to put me at 0, -1. And then I do the exact opposite to go to the other side. So I put a -1 here. So that makes -2, and this one is an equation. So it's x equals because we mess with the x. So to summarize what we did, all of the formulas, they have a 4p on the right side. And the letter that goes right here tells you which direction you can narrow down your graph to. If it's an x in that spot where I put the star, it's left and right. If it's a y, it's up or down. And then the other pattern, I'll show you the 4 things again. So you can have like this, or like this, and like this. If your p is positive and the graph is going up, that means that your dot ends up in between those two arms. If P is negative, that means this is going down and it's in between the two arms. Over here, if P is negative, that means it's going left and it's still in between the two arms. And if P is positive, that means it's going to the right, and that dot is always going to be in between the two arms. Now, depending on the direction of P, your directrix will always be opposite. So if you went up for P, you go down for your directrix. So your directrix goes this way. If you go down for P, your directrix will be on the opposite side, so you go up. If you go left for P, your directrix will be on the right. And if you go right for P, your directrix will be on the left. So that's just a quick summary. Hopefully that made sense. You can always, well, actually, when I see you guys again, I can help you out some more because we're going to have a couple days to do this stuff anyways. So hopefully this helps.